What are factorials? They're an arithmetic operation that takes in a natural number and multiplies it by every number before it, stopping at 1. For example, let's say you want to calculate 6 factorial. You're going to multiply 6 by every number before it, stopping at 1. That's going to be 6 times 5 times 4 times 3 times 2 times 1. This comes out to 720. Here's another example. Try to calculate 4 factorial. We do the same thing as before. Multiply 4 by every number before it, and then stop at 1, which leads to 4 times 3 times 2 times 1. This comes out to 24. As you can see, the obvious pattern makes it easy to calculate factorials of natural numbers. But trust me, by the end of this video, we'll be tackling topics of calculus like infinite improper integration to calculate certain factorials. But let's not go too fast. Let's get into the basics before we get into anything scary. First, we need to talk about what factorials actually mean in the real world. The factorial of a natural number can be seen as the amount of possible ways an array of objects can be rearranged. For example, take the first 3 letters of the alphabet, A, B, and C. In this case, A, B, and C can be treated as 3 objects. Then you calculate 3 factorial, which is 3 times 2 times 1, which comes out to 6. This means that there are 6 possible ways you can rearrange ABC, one of them including ABC, ACB, BAC, BCA, CAB, CBA. The second thing that I recommend you to know is that n factorial is literally just equal to n times n minus 1 factorial. We can prove this by just looking at some random factorial, for example 7 factorial. But if you look a little closer at this, 7 factorial just looks like 7 times 6 factorial. So we can take the group of 6 times 5 times 4 times 3 times 2 times 1 and turn that into 6 factorial to simplify 7 factorial into 7 times 6 factorial. This exactly proves the formula I just showed you. And if we input 7 into the formula, you get 7 times 7 minus 1 factorial, which is equal to 7 times 6 factorial. This really helps a lot if you are trying to calculate factorials by hand, because if you know the factorial of one number but not the other, then you could easily calculate the next factorial. Earlier, I said that 6 factorial is equal to 720, so we know that 7 factorial must be equal to 7 times 720. And if you are past the 5th grade, you should be able to easily calculate this, and it comes out to 5040. And this is where the easy road ends. I'm going to show you a bunch of calculus and complicated stuff, so if you are not above or at this level, I don't know if you should continue. Factorials get really complicated when we try to calculate the factorials of decimals and fractions, not just natural numbers, including negative numbers. But this is where our analogy that we explained before about how factorial represents the amount of ways an array of objects can be rearranged kind of falls apart, because there's not really a way to arrange half an object or arrange -6 objects. The logic kind of just gets destroyed. So if you want to calculate the factorial of a number that is real but is not a negative integer, then you use calculus, specifically the gamma function, which is defined as the integral from 0 to infinity of t to the power of the quantity of x minus 1 multiplied by e to the negative t dt. And we can use the gamma function and turn it into a formula that gives us a formula for n factorial. One of the crazy things is that gamma of n plus 1 is literally just equal to n factorial. So we input that into the integral, and it becomes the integral from 0 to infinity of t to the power of n times e to the negative t dt. And this will be equal to n factorial. And like I said before, this only works if n is a real number and not a negative integer. This is because of this thing called poles, which I won't get into too much detail in this video. But of course, doing this improper integration can get really difficult.
And the answers you get from doing the integration can get random and crazy.
Like for example, 1/2 factorial is equal to the square root of pi over 2. Like what in the world? But anyways, that is the end of this factorial video. This is my dog Cody. He is going to be my assistant in ending the video. Well, thank you so much for watching. Very complicated ending. Also a very cute ending. Do you guys think that Cody is cute or ugly? I think he's ugly, but as a joke, of course.